Okay, so here we are in processing. This is the coding platform. You have platform with several tabs on the top, and then you have two big buttons, stop and play. Okay, when you press play, you will find a little window that opens. This window is nothing for the moment. Okay, so we will start by drawing something in this window. Okay, first of all, we need to define two functions. Function setup with this syntaxes, and then I will define another function called draw. Look at the syntaxes. You have this word void, and then you have parentheses opening and then closing, and then you have curly braces, right? Everything between the curly braces will be encapsulated as a function. Okay, so the first function, which is called setup, runs once. Notice that I write here a sentence with two slashes. It means that it is not read by the program, it's just a comment. And then we have another function called draw, which runs indefinitely. Okay, it means this is a loop. Okay, so first of all, I will define the size of such little canvas. I will say something like, let's say 600 400. Okay, this is the size of the canvas. Look at this now. It's a little bit bigger. This canvas is gray, and I would like to change the color of the background of this canvas to something like, let's say, black. And I will write three zeros in the function or the method background, 0, 0, 0, and then a semicolon, as you see. And now the color is um, black. If I just write here 255, 255, 255, then the color of this canvas is white. So remember that this runs on a RGB color mode. It means that you have a combination of colors, red, green, and blue, and combination of these numbers will define a color as you wish. Now I put maximum red, 0, 0, green and blue, and you will see that I get red as background. Then I would like to draw, I don't know, let's say a rectangle. So I will write here rectangle. Um, the coordinate of this rectangle will be 200 pixels, and then the size of this rectangle, let's say 20, or maybe a little bit more, like 40 pixels and then 20 pixels. So if I draw that, what I see is a rectangle whose coordinates are 200, 200. I mean the left top corner, and the size is 40 pixels, the base, and 20 pixels for the height. Okay. Look at what if I do some. Well, this is not at all interactive. Okay, I just draw a rectangle and no more. I could also draw another thing like an ellipse, and I say, let's say something like this and something like this. This means that I have now an ellipse whose center is located at 300, 300, and the major axis is 20 and the minor axis is 10 pixels. Okay, so it is not interactive, it's simply drawings. But what if I put here, let's say, that The size of the major axis of the ellipsis is mouse X. Look at this. A little bit weird. I'm moving my mouse and I am getting a weird shape. We'll do the same with, let's say, the rectangle. Let me put something like mouse Y. And if I move the rectangle vertically, I see that it changes the size of the height. And if I move the mouse horizontally, I see that there is some change in the ellipse, but it's not very beautiful. It's a little bit weird. And the problem now we have is that we have set this background at the beginning, and we need to set the background actually as something that updates every time we draw. Otherwise, we will update this background, and then we will have the trace of everything that has been done during the process. So now if I do that, look, horizontally and vertically, so it's more fun now. So this is a very basic snippet, not at all um, difficult to present, few lines, okay, and I have a couple of applications. Here you can find interesting examples in the File tab. Examples here. I have several here. This is by default. You will find them, and I would recommend you to have a look on three of them for the moment. Let's go to basics and let's go to, first of all, maybe we can have a look of the clock. I think the clock is somewhere not control, data, form, not form, input. Yeah, in input, clock. Look at this clock. It's a code, it's a snippet, and if you press play here, what you will find is a clock. Okay, but interestingly, there are lines here, so you can find how to draw some lines. You can also find how to define how to deal with time as well. This is interesting. And see that this line is rotating as the seconds elapse. Okay, so this line has two ends, 2 points. One point is fixed and the other is being rotated at a certain angle. So this is an interesting code to study. Okay? Another code I would recommend to you is called Mouse 2D. This is interesting. Look at this. It's a more interactive one. It's shorter, it's very small. You see like 3 lines in setup and 1, 2, 3, 4, 5, 6, 7 lines in the loop, in the draw. Okay, and what it does is that since I move my mouse horizontally, the position of the rectangle changes, and if I move vertically, the size of the rectangles change interactively. So this is a good example to just understand how to play with mouse X or mouse Y function. Another example that I find interesting so far is called ARM. I think ARM is in not math, structure, or no, maybe transform. In transform, yeah, ARM. This one. Look at this one. This code is a little bit longer, and it has one couple of functions here called push matrix and pop matrix. You have information about it in the document. This is very important for rotation. But look at this one. So with the arm, there are 2 lines, 2 segments. Segments are thick. And the first segment here is vertical and second is horizontal. But if I move the mouse horizontally, the angle of the first segment changes. Whereas if I move the mouse vertically, only the second segment changes. Okay, so if I move it in both direction, I can just get some kind of movement of maybe something like a double pendulum or something like that. If I add some physics to this code, it would really have some realistic behavior. Okay, so these examples are, I believe, are quite interesting for to begin with. And of course, we can have much more info resources of processing. Okay, first info I recommend is to go to the web page processing, and then on the left part you will see reference, and reference you have all embedded methods and functions, or the vast majority. And if you click, let's say, to the ellipse, you will find what to put into this ellipse method. What does that mean? What are the parameters for this? What these parameters are for this particular description, or what's the syntax as well? Okay, that's for one, but you have this for all of them. Line, have a line, and you can find what these parameters mean, coordinates or sizes or so on. Okay. Anyways, we have prepared this document, and in this document you can find it as well. This is one source of information that we heavily and highly recommend. The second one would be have a lot of information with it, have it, and with that, what we would like you to do is to get into your particular curve. In this case, I have, let's say, Lemniscata. Have Lemniscata here, and you will see what we expect. Lemniscata, press play. Have here a curve. Okay, curve. This is a Lemniscata Bernoulli. And I have the mouse. Look at the mouse now. The mouse it doesn't generate anything now, but if I go a little bit close to the curve, you will see that now there is a line that appears, and the line represents a tangent line to the curve. We can see the tangent line, and we can also see the slope of this line at the left part, okay? Left part of the screen, a little canvas. Look at if I go, let's say here, or here, or here, along the curve I get the tangent line, which is the derivative. So that's a very important aspect, and that's what we want you to do. Draw a curve, draw the axis, draw the tangent line, and you can do it as beautiful as you can in this platform. Okay, so this is one of the examples. This requires coding, this requires differentiation, derivatives, and it requires, of course, creativity. So mathematics and art are put together in this little snippet for our challenge. Okay, so welcome to the challenge. Have fun, and I hope you will find it meaningful and interesting challenge for this course of math. So thank you.